Okay, is my screen visible? So, good afternoon to all of you. Today we shall see the standard template library. As I mentioned to you in my last lesson, we have a vector class list and one among them is also map. So, we shall see what these standard template libraries are and how they are useful in solving some real life problems. Now, we are all familiar with arrays, right? So, array is a static thing, but many real-time problems require a dynamic array. So vector is a solution for that. So as you can see, it is a dynamic array, and list on the other hand is a double linked list. Of course, I have to cover data structures where we have linked list concept. Few of you already know it, but doubly linked list we can traverse in either direction, and map is a balanced tree. Sometime in your engineering you might have studied binary trees. So there is a special form of binary tree. It is based on red black concept. So there is a red black tree also, which is most of the time balanced, so that whenever you perform insert, delete or search, it will always take a fixed amount of time. The searching time is log n as it is depicted here. Now when you want to create a array, you can specify the size of the array, and also there is one more parameter called as capacity. So we shall see what these two are. And once you create an array, you can resize it, or you can reallocate more memory as required. The array created by vector STL is very flexible. You can create initially with some standard size, you can resize it, or you can reduce the size, and you can access it randomly. So random access is what makes vector more preferred in certain situations. For example, you have hundreds of objects stored in a vector. So if you want to access any element randomly in fixed amount of time, then random access is very useful, right? However, on the other hand, list is sequential access. That is, if you want to get to any element in the list, you have to go from beginning till that point. And in map, the elements are accessed through what is called as a key, and obviously the time required to access the elements will vary from vector to list to map. So in vector it is random access, you can directly go to any element, whereas in sequential you have to go in list you have to go sequentially, and it is through key here. Now when we create any data structure, we always perform certain other operations like insert, delete and all. So if you want to perform insert in a vector, it is very slow, especially when you are inserting in the middle of the vector. That is because all the elements around that have to be shifted, so that takes certain amount of time. On the other hand, if it is linked list, if the position where you want to insert is known, then it takes constant amount of time. So by altering certain pointers, it will quickly perform the insertion. So whenever insertions are more in your application, you go for list. On the other hand, map takes log n time. So depending on how many objects you have stored in the STL, it would take log of n. So we shall see all these parameters when we evaluate the standard template libraries on different operations. Now vector allows duplicates, list also allows duplicates, however map does not allow duplicates, so this must be noted. You cannot have two elements with the same key. And if you look at how much memory each of these take when you implement them, so vector makes use of least amount of memory because there are no pointers to be used, whereas list and map, they take more amount of memory because you have to there are overhead associated with the pointers that they make use. So every node in the list has two pointers, one front pointer and back pointer, whereas in map also, when it is binary tree, every node has a left child and right child pointers. Okay, so these are the three different standard template libraries which are available, which we shall see today. There are certain variations of these which we can take up later. So let's first see how we can declare a vector and use it. So vector starts with a keyword vector, and in angle bracket you indicate what is the data type that you want to store. For instance, you want to store all the names, then this should be string. Okay, so vector angle bracket data type, then name of the array and all the objects that you want to store. So I am storing string constants here, so they will all be stored in the heap. So last time we had a confusion where exactly the objects of the vectors are stored. The variable names is stored in stack, whereas all these objects will be stored in the heap. Okay, so that must be noted. And once you have the vector, we can perform certain operations. For example, you can sort all the elements. So the way to sort is simply use sort algorithm. So you have to hash include algorithm library for this function to work. Sort, then you have to specify where the list starts or the vector starts. So there is a begin method which will tell you where exactly is your first object. So dot begin will give you this reference point, and names dot end will give you reference to this point. So all the elements between begin and end will be sorted. Okay, and if you want to reverse sort them, as the third argument you can use a functor. So in the last class we saw what functor is. So there is a built-in functor greater, and within angle bracket you indicate what data type the vector contains, string here, and opening closing bracket, just this. So within this there is a built-in logic that how exactly elements are compared and they are sorted. If this greater is a functor, how actually it is implemented, you can see here. It is a templates class T and struct greater. We have seen how functor has to be implemented. It returns a boolean variable, operator opening bracket, and it takes two arguments which are of type T. So it's a generic functor. It works for all different data type depending on what you pass here. So since your vector contains all strings, I am putting strings here. So this is a already implemented functor. You don't have to write it. We shall see how it can be made use. Now it is not that you can use only functor to alter the order of sorting. You can as well use a lambda function. Okay, so the method is again same, sort names begin, names end, and you know how a lambda function starts. It always starts with a square bracket, and within opening closing bracket, round brackets, you specify what are the arguments. So first argument is a string constant a, second argument is another string constant b, and within the body of this you just have to say return a greater than b. So what happens is each object is taken, it is compared this expression. If true, then the order will be properly maintained. That is, larger object will be stored first and the smaller object will be pushed to the next. So just by putting a lambda function, you can alter the order of the sorted objects. Similarly, you can use a lambda function to filter out the objects. It's not that you can use only for sorting like this. For instance, you have a vector containing all integer values. So as you can see, vector in angle bracket int have price is equal to some numbers here. Okay, and if you want to filter out only the prices which are above certain limit, let's say more than 100, so I will take one more vector high prices. So this is empty now, and we can filter out all the prices which are above 100. The way to do that is there is a built-in function called as copy if. So copy if prices dot begin, prices dot end, then back insert high prices. So this will insert all elements into high prices, those which meet this condition. So as you can see, there is a lambda function here, int price. It will take each price, check whether the price is greater than 100, and then push it into this high prices vector. And when you list them, you will get only prices which are above certain value. Okay, so we shall see the implementation of these basic things, and we shall see later how list and other things are used. So first thing, let us take a vector which contains only integer values, for instance prices. So within this we have certain values here, and vector has to be included here. Now vector has two methods which will tell some information about it. For example, if I say cout prices dot size, it will tell what is the size of this vector. As you can see, 1 2 3 4 5 elements are there, so it will give you the answer as 5. And there is one more parameter called as capacity. As I told you, if I say prices dot capacity, then now we have statically put some numbers here, so size and capacity will both be same. Let me put a NDEL here. Okay, so you get both 5 5. Okay, but when will capacity be greater than size? So if I can increase the capacity, okay, so here there are certain methods, prices dot reserve, and if I say 10 here, so it will reserve 10 places and the capacity will be 10 and the size will be 5. Let's see whether that is happening. As you can see, size of this is 5 because already 5 objects are there, but we have reserved 10 elements. Okay, so what will happen to the remaining 5? They will all contain 0 if it is integer values, right? So if you, yeah,
can you put the reserve above so that we will see whether the size will be 10? Meaning, even if we have set reserve as 10,
yeah,
we put that above, then can we try that out?
Yeah.
No, you just.
Yeah, it doesn't matter. You will still get 5 and 10. Okay. So let's display and see what is happening here for auto x colon prices. Okay, see out x and leave some space like that. So if these are integer values, the remaining 5 elements will contain, it will be reserved and it will not initialize to 0. But on the other hand, if you say resize, then it will contain zeros. So there is a difference between resize and reserve. If I say resize, now you see if I display, the remaining 5 will contain 0. There are 5 elements which are 0. That is memory is reserved, and the capacity will also become 10 if you say resize. Do you observe this? The size, the capacity is also 10 and the size is also 10 because the remaining 5 locations are filled with some value. But on the other hand, if you make this as reserve, okay, the memory is reserved but nothing will be stored there. So the capacity will remain 10 and the size will be 5 and nothing will be stored here. Okay, so there is a subtle difference between reserve and resize. You have to use one of them appropriately. They are containing integer values. Likewise, you can have string also.
Sir, for if you want to add some more elements into the prices vector list, we need to we might not able to do it at the end. Meaning we have to use the prices dot method of like a pushback.
You can do that. You can say prices dot pushback. You can always do.
No. What I'm saying is, can we just add directly like prices of 6 is equal to kind of thing?
Pardon?
Meaning how we insert in the list. Okay, if it is like prices of 6, that let us say like we have like reserve as 10. Okay. Now, if I want to add the 6th element instead of pushback, can we use some other way?
Yeah, you can use index. No, always.
Prices dot prices of 6.
You can do this. Okay, let us say Okay. You can always do this. Okay. So now if you run this, standard is not recognized. What happened? Okay. So let me comment this out for you.
Okay.
Standard is not recognized.
No, that is in system. You have given system of instead of C out. You have given the system of STL, right? That is what it is expecting it as a command. Standard.
This one.
Seventh line.
System.
That is
okay. This should be C out. No, yeah.
Yes. C out and
yeah.
No, it will not give it.
Yeah. So what should happen is at index 6 you should have.
Yes.
Is it still not working?
Yes, it is saying this size failed.
This size fails, sir.
Uh-huh.
It's not showing any error anywhere.
Yeah, it is not
Is
showing
it
me.
because of this? Because
Yes.
indexing is possible. There is no problem as such. Let me check. No, it works. Okay. Yeah. So unless you store something, it is reserved, right? Reserve means it is very much there.
Okay.
Uh,
Instead of 6,
can
you
we
just
use index to put that value there? Index 6.
instead of 6 you put 5, then we can just
No, even 5, 0, 1, 2, 3, 4, 4 we already have. Fifth one. No, it's not going through index. Maybe,
yeah, maybe we will just check it
yeah,
out later.
let's say through insert, let's see if we can do that, where we can say prices dot begin plus what is the index? Let us say 5
5.
and this value. So
Value.
now let's see if it can go through. Yeah, we are able to stop. Suppose
Sure.
if it is 6 here, then it should,
It should throw error, sir.
let's see. Yeah, 234 it is showing 2 times.
Right. But 289 is missing.
Yeah, 289 is missing. I think so. You have to go at the end and insert when you have reserved. You cannot
Okay.
leave anything blank.
Fine,
Okay,
sir.
so best thing is push back and use it like that.
True. Fine, sir.
So push back is what should work. 289, whatever.
Yeah.
289. So if there is enough space, it will insert at the end.
Okay.
Yeah. Okay.
Fine, sir.
So we can have a vector containing strings. Let us say.
Sir,
this
sorry
is-
to interrupt.
Yeah.
Sir, can you tell me about that capacity once again, sir?
Yeah. See, capacity is how many objects it can hold. Right now, 1, 2, 3, 4, 5 objects are there. Okay.
Okay.
And if you reserve 10, it has more capacity to include objects. That is, it can go up to 10. Now, your question might be what happens after 10? So, after 10, vector has the capability of enlarging the array automatically. It will make it 20. It will go geometrically increasing its size. Suppose you have only 2 objects. If third object comes, it will become 4. Okay, if you insert 4 elements, it will become 8. And if you have 8, if you cross 8, it will make the size of the or the capacity of the vector to 16. So automatically it grows in size, but before that, when you have, let's say you have only allocated 5 objects here, the size is 5, but there is no more capacity to accommodate more. If you want to reserve by yourself, then fine, it will, allocate some more memory to accommodate more objects. Okay, but suppose what happens if I don't do this? Now the size is 5, capacity is also 5. If you try to push 6th element, automatically the size of the or the capacity of the array will be increased to 10. Okay, so it will use some internal logic to increase the size of the array. As you can see, when you try to insert one more, the capacity has automatically become 10. It was 5 earlier, right?
Yes.
Okay, so that is why vector is a dynamic array.
Okay.
You don't specify the size, but remember the capacity can be greater than or equal to the size always.
Okay.
Okay, so that property should remember. Okay. Yeah.
Okay, sir. Got it.
Yeah.
Sir, just following up on that.
Yeah.
So capacity can be increased with any, I mean, is it dynamic? Like
Yeah.
suppose now
Capacity on its own it will increase, but if you want to increase yourself, then you use that resize or one more method. What is that? Resize and reserve.
reserve.
Yeah. Either of those two you can use to increase the size yourself. Manually you are doing it.
Yeah. So like if I have suppose 10 elements and it is complete, now I'm trying to add one more element without setting capacity, then the size can be increased like 15 or anything.
Yeah, you can increase and then add, or if you don't increase, automatically it will make it double of that.
Oh, it's double of that.
Yeah, double of it will always make double of that. If you have 10, it will make 20.
20, okay.
But you don't want 20, you are going only up to 15, then reserve 15.
Okay, so what is the difference between reserve and resize, sir?
If you reserve, okay, it will reserve the space, it will not initialize, put any values there. Okay, but if you resize, you can put some values. But if you don't specify anything, by default it is 0. Okay, for instance, now here, prices, if I say resize to 10, now let's see what happens. When you resize, capacity and size both will be 10, 10, 10, and values are initialized to 0.
0, 0.
Okay. Suppose if you want to initialize to some other values, let us say 101. Instead of 0, you will get 101. Let us see whether that is happening.
Oh, okay, everything is okay. All the.
If you don't mention anything, it by default it is 0. But remaining elements will be with some value. On the other hand,
So
if you say, yeah.
So reserve with reserve, it does not initialize it to 0.
It doesn't initialize, but it will allocate space.
Allocate space, yeah.
Okay. So reserve, you cannot specify the initial value, you just have to give a number. Now that is why you don't see anything coming up after this last number, 234.
Okay.
There is space for storing,
Yeah.
but it is not showing up.
Okay.
That's the difference between resize and reserve. Okay.
Okay, got it.
So some names here. Now these lists can be iterated using this for each loop, or you can use index also. For instance, for int I equal to 0, I less than, let us say, names dot size. Okay, size gives how many elements are there, and I plus plus. Then you can say cout names of square bracket this. Alright, so if you want, you can leave space in between. So let us put one more cout so that it will go to the next line with endl. So the names will all be listed like this. Okay, this is one way of iterating to the names. Another way is you can use an iterator, as I told you. Okay, so for vector string colon iterator it, which is equal to names dot begin. So begin will return a pointer. It will point to the first element, and then it not equal to names dot end. So until you reach the end of the list, you can use iterator plus plus, it plus plus. And using this iterator, you can display the element. So there are many different ways of accessing the element. If you just say it with the space in between, you can get all the elements listed again. This is another way of listing all the elements. Okay. So iterator is useful sometimes because it is like a pointer. It's not like your index, right? So you can start from the beginning of the list and go till the end of the list, right? Yeah. Now I can sort these and display. For example, if I want to sort all the names dot sort, again names dot begin, comma names dot end. Okay. If I just do this, they will all be sorted in ascending order. So the second list will come out. Okay. So yeah, one minute. This is not. That is not working with the vectors. You have to use another library here called algorithm, which comes up with all sorting algorithms. Just say sort names begin, names end. So let's see whether it goes through. Okay, so yeah, now elements are sorted. As you can see, Chetan, Girish, Ketan, all these are in sorted list. Okay, so built-in algorithm is there to sort the elements. This is ascending order. Suppose if you want descending order, then you can use a functor to do that. So that is called as what is the name of the functor? Yeah, name of the functor is greater, and you mention the data type, opening closing bracket like this. Now the same list which is here will be listed in the reverse order. Just see this. Okay, so the first is Savita and then Praveen and like this. So reversing the list is so very easy using a functor. So this is a built-in functor which will return true or false, and it will put the elements in ascending order. You can as well write a lambda to do the same thing. Okay, for example, the same thing I will copy paste and show you how we can use a lambda function to do the sorting in descending order. I will comment this out. So if you remember, we wrote lambda starting with a square bracket, and within the body of this you have to mention the object type and then the variable name. There are two objects required for comparison, first string and second string, like that. String, and you should use a reference variable because these are all objects. And within the body of this, you just have to say
String compare.
A greater than B, return A greater than B.
Question mark colon.
No, all that is not required. It will understand. It will either return true or false.
Okay.
Okay. So now also you will see the names will be listed in descending order. Okay. And if I reverse this, you will get in ascending order. Okay. So this list is coming in descending order. Okay. So you can alter the order of sorting either using a functor or a lambda function. Alright. So we have seen how we can create vectors of integers, of strings. You can have user defined type also in vectors. For example, we have an employee data. So how can I use employee data for name, which is string, then let us say float salary, okay. And in the type def I just say employee here. So how do you think we should declare a vector containing employee objects?
Vector of employee brackets.
Vector in angle bracket employee,
D.
all employees, some variable name, and then if you want to initialize these objects one by one, you can put name as, let us say, Kiran with some salary. This is second object, let us say some other salary. So we have two objects here, okay. And here if you want to sort, you have to use lambda function, because how do you want to sort? Do you want to sort on the name or on the salary? You have to mention, okay. So that is where the functor or the lambda function has to be used. So to display this data, I can say for auto, let us say EMP from all EMPs. It has to be a reference variable, and here you can see out emp dot name with little space emp dot cell, and you can put one cout. So this will of course list the employee data. Okay, so Kiran 5000 and remove this. Right. Now, if you want to sort and display, right? So should we? Okay, so what we can do is put one handle here so that they are on separate lines. Okay, now how do I sort this? You can use sort, then all employees dot begin, then all EMPs dot end. So if you only give this, it is meaningless, right? Because you don't know on which column you have to sort. So this is where you mention employee ampersand, you can use E, and then within body of this, there should be two objects, right? Employee E1 and E2. E1 comma employee E2. And then here you compare the two things. Return what?
Return A less than B.
Return E1 dot. You want to compare names or salary. So let's say on salary you want to sort. E2 dot salary. So on salary they will be sorted in ascending, descending. What happened?
Semicolon at 19.
At 19 semicolon. Yeah. Okay, so as you can see, you got the two objects sorted on salary descending order. Okay, so if you wanted ascending order, just change this to this. And if you wanted on the names, you just say name. Let us make it greater so that Vinod will come first. Right? Okay. So we can create vector of different data types. Intrinsic type like int, then built-in types like string, and also user-defined type like employee. Okay. So would you like to give a try this?
Struct pointers,
Pardon?
pointers to vector.
Array of pointers.
No, I'm saying like the way you have passed employee as a user defined data type, right? If I want to pass a struct pointer,
Here,
Vector.
here.
yeah.
Yeah, it's possible. You have to store, it will be array of pointers. And you have to create objects and pass addresses of the objects here. Okay. So it is possible to store array of pointers also. Okay. So first give a try on these simple things and understand. We shall see more of these things a little later. Okay.
Hmm.
Would you like to try this?
Yes.
Okay, just give a try quickly. So I have only a small thing to cover. I will just go along, and if you are still carrying out other things, you just observe. Now there is one function called copy if. So what this does is it will filter out those prices which are below 100. Okay, and store only those which are above 100. So high prices like 110, 200 and 234 will be displayed. So if I for auto price colon high prices cout price. Try this also, that is how to do filtering using a lambda. So as you can see, we got only these three in the output. So various things are possible with vectors, and this is one possibility where you want to filter out certain objects based on some condition. Same
So
thing.
this
Yeah.
copy is taking 4 arguments or 3.
Pardon?
So how many arguments this copy is taking?
Yeah,
What is the same?
this you can see. There are 4 arguments. One is the begin, second is end, third one is back inserter. That is, you have to insert filtered values into this new vector based on the lambda output. So there is the lambda function here last.
Cannot do without lambda. Lambda is required.
But then how will you specify the condition here?
So we can take some function now, like I want to create my own function.
Yeah, that way you can do. You can write a function to filter out elements which you want. Put a for loop and say if price greater than this, and you print. See, we have seen lambda functions. They are, you can inject lambda into an existing function. So copy if is a function into which you are injecting the lambda here. The advantage is the lambda can be anything. Now that you are putting price greater than this, then you say price less than this or some other complex expression here. So accordingly the filtering happens. And if you have many lambda functions, you can pass whichever one you want. And if you are using list, it is again the same. Just say list in angle bracket, let's say list prices, something like this. So only thing that changes is the keyword list here. Everything else is the same. So both look the same. And what you have done with vectors you can very much do with lists. So if you want to insert something, list prices dot pushback or insert, you can do that. If you say pushback some value here, that will go at the end of the list. And again you can display using so if you learn one STL, you can learn other also very easily because they are similar. However, map is little different. So it is displaying this 33, 42 and all. And if you want to use map takes two arguments. Okay, so it's a key value pair kind of a data structure where first part is called key, second is called value. For example, you want to store a name with this ID, so you just say int string like this and just say all names, and you again have to include map here, hash include map. So it is a binary tree which will store, there should be a comma here. So how do I store the data here? So all names of 100, let's say the ID is 1000, then you have to specify the name. Okay, if you want to know the name, you just have to say all names of 1000. So if it exists, it will give Girish as the. So this is one of the ways to insert data into a map. So map will search for this employee with ID 1000 very quickly compared to list. In list it goes sequentially. So imagine you have 100 names stored. So don't use list when you want to search for a name given the ID. So always use a map. Okay, so maps work much faster. As you can see, the Girish is coming out at the output. So it is also possible to insert the data. Okay, so likewise you can say map dot insert first key and then second value. Okay, so here you can, after this, if you can all names dot insert, first is the name ID and some Chetan like this. Does it accept a flower bracket? I think so. Flower bracket is needed. Yeah. So this is the way to insert a key value pair inside a map. And now if I change this to 1001, you will get Chetan as the output. So there are two objects now in the map. Okay, so as you can see, Chetan has come out as the. Okay. So given the key,
Sir,
you can find
is
the
there
value.
any way that we can print all the contents in the map?
Yeah,
If we just can say like,
that should be possible. No, again using for each loop, we can do that.
okay, no, other than that, I'm just asking like if other than that, can we just use all names? Then can it be printed? See out all names.
No, no, you cannot do like see out all names. You have to iterate through the list. It is like a binary tree. No, how do you go node wise? It should be through the hierarchy or through the key. Given the key, you can display the value.
Okay, okay.
So this again can be done using the for each loop, and you can display all the objects in the map. Fine. So we shall see more of these list methods and map methods in our next session, because some more time is required to make you go through the list, what are the different methods which are available and what all you can do with the list, and then also maps, how maps are actually used in real life scenarios. So that part we shall take it up in our next lecture.